Alright, hi guys, my name is Caleb. My presentation is on food in the future. Hopefully this will get us a bit more hungry for dinner. Okay, so
Food in the future.
food is one of the cornerstones of the three basic human needs. Food, however, as a resource is limited, and as Julie was mentioning earlier, we live on a finite planet and scarcity is one of the biggest problems that we are trying to accomplish. So much so that Singularity University has said that food is one of the 6 grand challenges for our future. And to overcome scarcity, scarcity has always traditionally been overcome by technological change. Now, how does technological change and human society and food kind of all interrelate? Well, technological change has, like I said, changed human civilization every single time it has come around. And food scarcity has always been tackled also by technological advancements. Together, the ability to face food through technological advancements has changed our culture and our society often irreversibly. So just to give you a bit of history, if you look at the hunter-gatherer lifestyle, which was the primary mode of production for most of human civilization, it was actually characterized by a lack of surplus. You could go hunting a deer or something, but you couldn't keep it for the next couple of days, like we can just shove it in a freezer today. And because of this, everybody in society would contribute equally to food gathering. And therefore, there was actually a lack of a social hierarchy. In this case, food would dictate social organization. Now, over time, however, technological advancements meant that the development of agriculture soon came around. And in this case, when agriculture came around, we started to have the ability to create surplus. We could make more wheat or more grain than we could eat all in one day, and we could store that in a silo or something. And an agricultural society led to the rise of feudalism, where peasants gave their food and all the surplus to the nobles. Once again, however, food dictated social organization. Now, in 1910, a huge disruptive technology was created, and this was called the Haber Process. If you're not aware of it, the Haber Process was first was created by a German named Haber, and the Germans used it during World War I to produce a lot of explosives. But after World War I, however, it was used as the mass production of ammonia, which is the key element in fertilizer, and greatly improved our fertilizer and agricultural productivity. So actually, because of the Haber Process, we were able to have a global population explosion from 1.6 billion in the 1900s to 7.4 billion in 2015. And I think it's important to point out that scarcity is now returning somewhat on a global scale, but in a bit of a different way, because the UN actually reports that we make enough food to feed our population. However, it is a known fact that global hunger is a concern. So what actually causes global hunger? So poverty is the first one. The food may be available, but doesn't mean you can buy it. Second is conflict and political instability. You could go to a war zone, and there may be food in the war zone, but you might not have any way to access it safely. The third is global warming and climate change. That is actually a very important point that is very salient in today's society, because if you look at some coastal regions where a lot of food is being produced, the sea level is rising, and it kind of floods over those coastal regions and destroys agriculture. And finally, of course, inefficient distribution. A lot of food may be produced in one place but cannot be distributed to places that truly need it. Now, what about the future population? We might be able to feed our current population, but how about the future? In 2050, we are projected to have 9.7 billion people on the planet. Food demand will increase by 59 to 98%, so almost doubling. Technological change must occur in the face of scarcity. And so I would just like to walk through some of the technological changes that are currently occurring towards developing sustainability. The first off is, it's not really new, but GMOs. We're trying to increase more GMOs, having more advanced crops to create more disease resistance, climate tolerance, nutritional output, and of course photosynthetic ability. Now, the important revolution in recent years is CRISPR-Cas9. This will allow you to do rapid prototyping of genetic modifications to see which crops gives you the best yield and best outcomes. Next is entomophagy, which basically means eating insects. I don't know if anybody of you have eaten an insect. I have. It's not bad. But eating insects is actually interesting because insects are extremely good at converting feed into protein. They have extremely high efficiency in that sense. And actually over 2,000 species of insects are eaten globally, just not in Western countries. However, there are some problems, and as that is toxicity. We aren't 100% sure of how clean the insects are and how safe they are to consume, contamination of pathogens, and potential allergies. And currently you can see a President's Choice sells cricket flour. It's not really on a mass scale yet, but they sell it $13 a bag. Okay, and the last one I want to talk about is lab-grown meat, and this will be kind of the topic of my presentation today. So the UN reported that raising livestock requires 30% of global land, 8% of global freshwater, and produces 18% of global greenhouse gases. Meat demand has only skyrocketed over the past few decades. Lab-grown meat requires, however, significantly less resources. If you can see from this graph, this pink bar demonstrates lab-grown meat. Hypothetically, if you were to use a nutrient that is cyanobacteria-based. And so you can see that energy use is decreased from the black bar, which is beef, greenhouse gases emissions, land use, and water use is significantly decreased. As well, lab-grown meat has the advantage of being very safe because you have to grow in a very tightly controlled and regulated sterile environments. Now, how does technological singularity interact with or intersect with food? Just to recap, the technological singularity is the idea that in approximately 2045, computing power will be so great that it will be greater than all of our human brain power combined. And the rise of hyper-intelligent AI will bring about this exponential technological advancement and give rise to unfathomable changes in human civilization. I would propose that food will be an essential component of these unfathomable changes to civilization. Because once again, food, culture, and technological change is intricately linked. So with advances in biotechnology, food-grown meat I believe, will likely be the future. Okay, so just a bit of history of lab-grown meat. Winston Churchill in 1931, so a couple years before World War II, said that in 50 years, we'll basically be able to eat a chicken without growing a chicken. It's been more than 50 years, but in 1994, this physician, Willem van Elen, first put some patents forward for lab-grown meat. In the early 2000s, NASA funded a proof of concept project to grow lab-grown meat, while there was another, I think, separate project with some bio-artists to make lab-grown meat. In 2005, the Dutch government poured quite a bit of money into cellular agriculture, which is the research towards lab-grown meat. Now, in 2013, this was a key landmark because the first lab-grown burger was created and eaten. It cost $330,000 to make it, and it was funded by Sergey Brin. If you do not know, that's the co-founder of Google. At the time, people said it tasted like an animal protein cake. I don't know if that's very tasty or not, but actually, funny story about that one is that when they cooked it, they said they used a copious amount of butter to fry it up. So today, however, many startups internationally are trying to work towards lab-grown meat. And these startups, you might never have heard of some of these names like Mossa Meat, Just, Superfoods, Memphis Foods. But some of these startups have very, very high-profile big companies behind them and supporting them. I believe some of them are funded by Bill Gates. Some of them are funded by Tyson Foods, which is one of the largest food industry companies in America. Now, how is lab-grown meat actually made? What you do is you have your cow that you want to start with. You take a biopsy sample. From that biopsy, you extract stem cells, and you grow up the stem cells in a nutrient broth, essentially. And from here, the cells will proliferate and just grow and grow and grow, and eventually you'll basically pop up with enough cells to put together a burger. For the most part, the cells that they use muscle cells, so they call these myocytes, but you can use other types of cells to have proliferation, so fat cells like adipocytes, because we know fat tastes best. Okay, so, however, there are some technological limitations currently, and that is that starter cells you can grow a ton of cells from only a few starter cells, but if you keep growing these cells for a long time, you can accumulate a lot of mutations. Another problem is that fetal bovine serum is the growth media that they currently use, and it's actually very expensive. It's about $1,000 for a liter, and on the more socially relevant side is that fetal bovine serum is only obtained by killing cows. So you're kind of shooting yourself in the foot here because you're going contrary to the idea of being animal-free production. So vegans probably won't really like this idea. And finally, that's the idea of a scaffold. So to grow meat, typically you want to grow it on an industrial scale, and you need to grow it in like a 3D structure. You can't just put cells in a plate and expect it to grow into a huge mound. It doesn't really work that way. So the choice of scaffold needs to be thought up. So some ideas are to use a collagen scaffold that you might be able to eat afterwards as well. Okay, so, and once again, societal variance. The $330,000 burger that was made in 2013, they managed to bring down the price to $80 per kilogram, which is, if you ask me, that's a very significant drop in price. However, $80 per kilogram of meat is still very pricey compared to what you can get at a supermarket for like $10. There's this perception of lab-grown meat being franken meat. People don't already like GMOs. I can't imagine how much people detest eating meat that's never been in an actual animal before. And finally, taste. That is a very big problem because it's not yet up to par. People probably don't want to eat food that doesn't taste good. As mentioned before, that burger tastes like an animal protein cake. So this picture here is from Aleph Labs or Aleph Foods. It's an Israeli-based company. They claim to have managed to make a steak, and this steak costs $50. However, the makers themselves say that they need to work on the taste of the food. And I'm not sure if you can see very clearly, but the thickness of the meat here is rather thin. It's kind of like just a really thin piece of steak meat. Okay, so how will the technological singularity affect lab-grown meat? And so a few points is the first off, super artificial intelligence and exponential biotechnological advancements. With artificial intelligence, we'll soon be able to parse through vast quantities of biological data. So we'll be able to fully understand genomics, proteomics, and metabolomics, the key components of what makes up different cells. And using this data, we can improve food quality. This data is actually very important because this will allow us to create the perfect growth conditions to be able to fully replicate natural cell growth, which and hopefully will be able to perfectly replicate taste and texture as well. And so some of the factors are the serum, what the cells grow in, the growth factors, and the scaffold. AI will help us kind of understand this. And just to give an example of how much data there is to kind of go through, this is just one cell responding to insulin and some of the pathways. And we don't know everything about these pathways, but hopefully by the near future, we'll be able to use AI to parse through all these vast quantities of data. Okay, so the next few things is that technological singularity. With advancements in biotechnology, we can industrialize cellular agriculture. We not necessarily need to, we can also localize it as well. So your food doesn't necessarily need to come from China anymore, like your ton of rice comes from other nations, but we could do it right here in Edmonton because we can have it in these little bioreactors and just grow it on a local scale. Another really cool thing is that luxury foods could become more common because there's nothing stopping you from growing food that is not just meat or beef. You can grow rare foods because all you need are the starter cells. And finally, once again, you can have a great increase in safety and nutritional value. So here are just some examples of very expensive exotic foods. This is matsutake mushrooms, cost $600 per kilogram. White caviar, $9,100 per kilogram, because the fish that makes these has to be 100 years old before they can even produce these eggs. Wagyu beef, steak, I'm sure some of you have heard about, one of the most expensive steaks you can get in the world. And finally, white truffles that cost $2,000 per kilogram. This is very expensive. These two are very expensive because you can't actually grow them normally in like say a greenhouse, and they require very specialized methods to find and dig up and preserve. Now, just to kind of go through a bit more, challenge of the technological singularity is the unfathomable changes due to accelerating change. So how can we predict the future, and what can we predict? We'll almost certainly see an explosion in biotechnology, nanotechnology, and artificial intelligence. Now, however, not many people have talked about what food in the future would actually look like. And I'm just going to show you just one or two examples of what some people have thought of, and that is Wall-E. So, I don't know if you watched the movie, but these guys are eating their whole food, their entire meal, all through basically like a milkshake. And this one I believe is cupcake in a cup. So that is their version of food in the future. Currently, we actually have a bit of an analog, and that's called Soylent. They claim that it is a full meal replacement with 20 grams of protein, 21 grams of fat, and 26 vitamins and minerals. It's soy-based, so it's vegan, and they claim it's easy to consume, and you can actually make some of it at home yourself. However, food, I would argue, or the experience of eating of food is an innate part of the human experience, and as food changes, so does our culture and society evolve as well. The Soylent that I mentioned earlier, someone tried it and they called it a punishingly boring, joyless product. To be fair though, that guy drank it for like 30 days straight without eating anything else. And I think at a fundamental level, food really is an expression of art and creativity. And I believe that in the future, in this technological singularity, food, culture, and art will experience a renaissance in availability, creativity, flavor, all through the promise of lab-grown meat or food. And just to walk you through some key points is, first, I believe lab-grown meat will become localized, fresh, and on-demand. And I think this is actually deceptively important, because to be able to produce food on a local scale means that you can significantly reduce waste, and you can have it on demand when you need it. No longer do you have to estimate how much food to import, but you can have it just do it on a much local level, which is significantly better. As well, fresh food is very important. We all know that fresh food preserves a lot of nutrition and enhances food quality and prevents spoilage. Fresh food is a luxury. As well, like I mentioned before, exotic foods may become a household staple. Now, the next thing is significant food culture globalization. We all know that you can go to Chinatown and buy some noodles, or go to a Vietnamese restaurant to eat some Vietnamese pho. And food has been globalized all around the world. However, I predict that it will be even more so, because you see the authenticity of taste in a lot of food when you go to, say, Chinatown, is not exactly up to par. I'm a bit biased because I eat a lot of that food before I moved to Canada, so I can kind of taste the significant differences there are, but it's very hard for me to find food that I really find authentic in Canada. And I believe that this is because store-bought international ingredients are often very prohibitively expensive. It's either frozen or it's old. And this means that you cannot capture the true taste of international food. However, growing food fresh and locally resolves this problem. And because of this, I believe that food culture and food heritage will be greatly shared across the world with great authenticity, and AI will actually play an important role because it's able to look all around the world and look at the cultural techniques of how people create food and implement it all across the globe. And here is just a picture of saffron. It's also one of the most expensive spices in the world, and it can only be grown in like Tibet, but without this key spice, your food doesn't taste the same, or at least the food in that culture. And finally, I believe there will be an exponential increase in culinary art and works. So this is, anybody want to guess what this is?
Oh, it's water. Or like a cake? Like
Yes, it's a water cake. This is literally a water cake. It's made of agar. I believe that culinary arts has always been limited by available ingredients and technology. But in times of cultural and technological change, the culinary arts has also evolved alongside. For example, with the introductions of Indian spices to Britain, you had Anglo-Indian cuisine. With the invention of refrigeration, you had cold desserts or frozen treats. This one, in order to make this, you need to have agar powder, which would not have been available like 100 years ago, and you needed to have refrigeration. This, I would believe, is an example of what I mean here. Cultural and technological changes be able to produce a very gorgeous work of art, of food, if you ask me. And that's just water, really. And so, as mentioned before, food localization, culinary globalization, and unconceived technologies will provide this explosion in culinary arts. People are curious and they like to experiment. And I believe that with having the fresh ingredients of any kind that you want, having this global knowledge through the help of AI, of any cultural heritage and techniques, and having advancements in food sciences will really allow people to experiment with so many different kinds of food combinations all around the world. So, like I said, it will enter into a new global of experimentation and food creation. And so just one example would be a dodo bird. Have you ever wondered what this tasted like? Because you could grow that with lab-grown meat, possibly with just the DNA. You could perhaps make a hybrid steak. Have you ever perhaps wondered what a hybrid between a cow and a lamb would taste like? You might be able to do that with lab-grown meat. And I think really you could just combine and pair a lot of food that would never have interacted before, from say Western cuisine with some African cuisine, and you could just combine all the different foods and spices. And I think that's pretty exciting. So to just give, I guess, a bit of personal story and example of what I'm kind of getting at is this. So these are clams. They call them blood cockles in Malaysia, where I came from. These are actually very cheap. This plate costs 50 cents. I think they're very tasty. They're called blood clams because if you see here, it kind of looks bloody. It comes from the high hemoglobin content on it. However, there are some concerns with these clams in Malaysia, and that is there's increasing price. The clams are dying because of contamination in the water from factories. You can actually get hepatitis A eating these if you're not careful, because these are bottom feeders. They filter a great amount of seawater and absorb a lot of the contamination. And if you eat this and they aren't clean, you can get hepatitis. And finally, there have been some attempts at aquaculture, but it hasn't been very effective. Now, I think that's a great example because if you think about it, if you can grow these blood clams locally and freshly, I would be able to enjoy them here in Canada. Currently, I'm not able to do that because if I were to buy them, they would either be frozen or not good quality clams or very expensive. They would also be very safe because you can grow them sterilely in very regulated growth conditions. So hepatitis A, I hopefully will not contract. You might be able to cook it in different styles. You might be able to cook it in, like, say, a very fancy French fusion sort of style, or more of the side of the road, like a New York style. And finally, if you ask me, I would want to try these clams with different foods. So I would like to try it with truffles or mushrooms. I don't know what it'll taste like, but I'm sure it'll be good. So I guess in conclusion, as I presented earlier, food and technology and human civilization have always been very tightly interconnected. Technological changes drive human society and food culture as well. It is quite hard to predict what will happen in the singularity, but we might be able to predict the future of food. And I believe that humankind loves the experience of eating and the experience of food, and this food culture will not go away in the future anytime soon. I believe that the future of food will be some sort of lab-grown meat, combined, of course, with more scientific advancements in genetic modification. Food will be localized, fresh on the demand. There will also be more globalized, so you can experience a wide variety of culture and cultural foods. And finally, the culinary arts will have an explosion of works. And lastly, just to kind of end everything up, I believe that food in the future will build on thousands and thousands of years of culinary experience and innovate in different ways to bring us new experiences to our food palate. Thank you.
Do you have any doubts about whether the lab-grown meat will ever get there? I mean, I saw the word metabolism. Is it possible that it'll just turn out that in order for it to be really tasty, you have to do more than merely replicate the cells?
So I just want to head back to this image here. So in this one, the makers claim that they have some work to do on the taste department, but actually when people have eaten these, they found it to be very similar to real meat. The thing is that meat also has a lot of difficulties, so texture is very important, the way it kind of melts in your mouth. And steak is actually quite challenging because it combines many different cells and many different textures to have its kind of taste. And right now this is, I guess, the state of the art. In 2013 they had the burger, because burger is just like meat paste. So I don't really have doubts that we can get to that point, because just within such a few short years they're able to create a steak. It might not be a very fat steak, it might not taste 100% there yet, but in just 2013 to say 2018, that's 5 years of progress, and they've managed to create something I think that is very remarkable. Yeah, go ahead, Julie.
I'm just kind of curious about the process. Like you mentioned, using a bovine solution and like a lattice. Could you just walk through like the ingredients that go into this?
So what you do is you want to take cells out from a cow. These cells have to be stem cells so that they can grow and proliferate. You basically put them in a nutrient supply, so just a bath full of growth media. Most cell culture labs also kind of do the same thing. You put cells and you put some media and you just have full of nutrients that they can grow. This media is called FBS, fetal bovine serum for the most part, and it contains growth factors, proteins, amino acids, just whatever a cell needs to grow and be happy. People don't actually truly know what makes fetal bovine serum so effective, but it's just what everybody uses. And so they grow these cells on this scaffold. So the cells actually need somewhere to sit down and plant itself and anchor itself so it can grow around it, which is why the scaffold is very important. And after a while, the cells will kind of come together and form these myotubes, which are the preliminary precursors to muscle fibers and eventually into meat. Now, I'm only talking here about muscle cells, meat cells, but you can theoretically do this with fat cells as well. Anyone here?
I might have missed it, but on the kind of the vegetable fruit side, is that going to be the lab side as well? Is that going to be kind of more vertical farming type technology?
So currently they've only been working on meat, but I do believe that in the future it would definitely be possible to grow vegetables as well. Because I guess I forgot to mention this, but the reason why lab-grown meat is able to achieve such its high efficiency is that you don't need to grow things such as bones or any unnecessary organs. You just need to grow what you want to eat, right? So, for example, I mean in this case you want to eat all of this completely, but you could, I'm just trying to think of an example. Okay, so for example, you can grow like a fruit perhaps in lab-grown meat, and you can only just grow the flesh of the fruit without the seeds. So that might be an example there. Yeah.
So just building off of that, do you see any kind of risk in terms of kind of global inequality with that happening? Because theoretically you'd be able to increase production significantly with that.
Yeah.
But it'll also probably be most likely the more developed rich countries with access to that.
Yeah.
And so they import from kind of those developed countries that rely on kind of those economics of exporting food. Do you see any kind of potential issues with that? Kind of what steps would you take to kind of mitigate it?
Yeah, so I think like I mentioned a bit earlier, so the reason why we have global poverty, or global food hunger, even though we are able to produce enough food, is, like you said, because of global inequality. I think that, of course, at the start, this technology would likely be for people with the money to make it, but I think that in the long run, this technology will be able to get down to be much cheaper, and I think the reason, like I said earlier, the thing of localization, being able to localize these food production areas to cities or even your individual house, that will be able to help work against global inequality. And once again, of course, the rich people get access to it first. But I think if you look at programs such as one laptop per child that aims to provide, like you said, one laptop for every child across the world, even though laptops used to be this item of high prestige, nowadays there are organizations that do want to do good in the world and provide these necessary resources to everyone else. Okay,
so I just have a quick question about how you talked about like these facts and figures on how there's enough food in the world to feed everyone right now, right? But So a lot of the exotic foods we eat come from, like, for example, like South America and Africa, right? These very underdeveloped nations comparatively to the Western world. So all these nations have very export-driven economies in terms of the food sector. So, but with this new lab-grown meat idea, there'll probably be predominantly be Western countries implementing this new technology to feed their citizens, right? So at the same time, like, if you have this new lab-grown meat coming out for like $50 a day, but you still have this cheap meat being created by your own citizens, like your own farmers here in Alberta, for example, that are a lot cheaper, right? Do you think there'll be any pushback between, I guess, just international opposition to this and just local as well?
Yeah.
But also, do you still think, like, even with this new abundance and new food source, that will even be able to come close to feeding everyone? Because there's still going to be the people who have and the people who don't have.
Yeah. I'm not going to make any, perhaps say, grand claims that will be able to completely eliminate global hunger. But I do believe that this sort of methodology would be kind of a step forward. And once again, I think the reason is mostly lies within this slide here, that beef production and all these other agricultural forms take so much land, like compared to the amount of land used for beef and to cultured meat. It's just a significant difference. As to answer your question about local food and stuff, I also don't think that we'll replace traditionally farmed livestock anytime soon, actually, because if you think about it, there's people who don't want to eat GMO foods as well, and they all pay the premium for organic beef, organically raised chickens and stuff. And so I think that plays a very similar analogy here. This will be, I believe, a step towards trying to solve global hunger and global scarcity, but it's not necessarily a luxury. Whereas in the future, perhaps land would be a luxury because of how limited we have. Julie?
Just kind of building off of the point that you were just mentioning as well, we've talked in class about like if you would need the consent of someone to say have them interact with like an AI therapeutic robot or something. Similar to this, do you think that aspect of consent is important, and like would people at some point in the future even know if their meat was being lab grown, or like would it just kind of be like part of the pool of all like food that we eat?
That's a good question. I think that people would actually know that. Well, maybe like 300 years from now, this knowledge might be forgotten or taken for granted. But I do think that in the near, at least by the time of the singularity, or within 100 years at least, we won't forget that food could be grown in natural livestock. And I think by the time you hit around where it would kind of be forgotten, that would be far enough in the future, I think, that it would be a necessity to do this kind of food production, because you just won't have enough land unless you start colonizing Mars or somehow find a different planet to go to.
I was just gonna comment because I don't know if it I forget if it was, I remember now, I don't remember if it was kind of like more like Beyond Meat kind of stuff, but
Yeah.
there was some pushback by some American like meat farming associations regarding what you can call meat.
Oh,
and
yes.
I think lab grown stuff was under that.
Yeah, so yeah, they do talk about that. I came across a few of those articles, and they do mention that some American meat companies do want to specifically say that lab-grown meat is not meat because it doesn't come from a cow. You don't do it livestock. However, I do want to point out that these companies, Mossa Meat, Just is actually a Mayo company. I'm not sure if you know that. And they used to go by Hampton Creek. So some of you might have heard of that name before. So some of these companies are actually funded by, like I said, Tyson Foods in the States. Tyson Foods is one of the biggest food, like I said, companies in the United States, and they primarily work on traditional livestock foods. So to me, it shows that these huge companies, where all their entire investment and all their work on is for traditional farming techniques, are willing to invest in these startup companies at a time where this technology hasn't even been perfected yet, showing me that they themselves believe that this is going to be the future as well. Yeah.
I'm just curious, how long does it take to grow like a steak? For example, they're like thin. I'm just curious.
Great question.
It'd be like exponential, right? Like. It's
I don't actually have a solid number for you. A lot of this research is kept very tightly under wraps.
How long do you want it to take?
I think it'd be good if it was like 24 hours. I think realistic to grow.
I think you could get to that point once you hit singularity. Yeah. You just, you just need enough cells to start.
It's like a toaster.
Yep.
So I don't know if you've heard, but in Tokyo 2020, they're pushing out this sushi singularity thing where they're like 3D printing sushi with like some food gel or something. So like, what do you think? Like, is lab-grown meats gonna be used with 3D printing in the future, or do you think it's just gonna get
Sure.
pushed out?
I think that the great part about I guess human civilization as a whole is that you can have a wide variety of different things that don't have to be mutually exclusive. And so if you mentioned about 3D printing, I could also bring up a similar topic of perhaps nanobots. Could nanobots put together our food for us in the future? So if you think about a scaffold, each of these cells right here are similar currently, but each of these cells do not have to be similar. You could have a meat cell here, an adipocyte cell there, so a fat cell. You could have different kinds of cells wired in a different way, and you could grow, in a sense, your 3D version of the meat that you want. So no, I don't think that it'll push out necessarily. I think rather it'll live together in harmony as a different technology that can be utilized either by lab-grown meat, or lab-grown meat will be utilized by the 3D printing technology.
Probably the fiberglass needs to be considered too, because in actual meat you have,
Yeah.
you know, fibrous tissue there, so your taste buds are kind of used to having the
Yeah.
tasty stuff divided up by
Yeah.
this fibrous
Yeah,
tissue.
and that's kind of what I was talking about when I mentioned texture. This is actually a picture of that 2013 first lab-grown burger. If you see it, it doesn't really look like a beef patty. If you ask me, it looks like way too uniform. It looks too like.
It looks like my mom's salmon patty.
But if you look at this steak, though, once again, I mentioned this steak because when they created this steak, they mentioned specifically that they needed to use many different cell types. So I would think that fibroblasts would be one of them to produce this steak. And if you look here, there's actually similar kind of striations in the meat as well. So and the people who did eat it did mention that the consistency was pretty good. It's just the flavor was a little lacking.
Yeah,
Mm-hmm.
cool.
It's the same problem you have in choosing steaks today. You can go for the perfect texture,
Yeah.
which probably isn't going to have the optimal taste.
Mm-hmm. Or you can eat this.
That's not at all.
Well, if there's no more questions, thank you very much.
Thank you.